Hey, hi all, welcome back to my YouTube channel. So in this channel, we are going to make you guys as a AI native engineers. So already we discussed about what is our 6 month map, mastery AI roadmap. We have already discussed. So in the last class we briefly discussed about what's how the ML, AI, ADL those terms are came into picture and what are the difference and history behind it. So today let's see one of the major, which it is a very good example that I have came across. So this is taken from the MIT and professor's lecture. So here let's see the thing that this is the classical programming example. So we are giving two inputs. One is rules. So how the classical programming, or even if you are a coder, then how you guys are programming is that we will be giving rules plus data, which is nothing but input, not AML data. So then what it will do is that it will give answers. So we know, means the program will execute and something will happen. It will give answer. Okay. But in ML, what we have giving the input is that we will give the same input data, but the input is here the huge data set, and then we will give answers. We will give, we will train. Even we can state this as a training, but the data and answers we will provide. Then ML itself will create a rules. So this is the very good and quite difference of the things. So once you guys were familiar with this, then you guys will be able to rock it. So major difference is that we are giving rules and data, it will produce answer. When we give data plus answer, it itself creates some rules. So with these rules, even the data may changes, even if the answer is not given, it will produce some kind of things. So this part, this the giving input and the answers are already completed by many kind of companies like now the ChatGPT, Cloud, Gemini, everything is there, right? So they have already made these things. So we are just giving different data and we are getting some the rules is updating from itself. Even we are getting answer here, but that thing we are not coming into this picture. How we are making is the training part, the initial part. We are not into the advanced thing, right? So this is just a foundation course. So in this course, we will be letting know how the AI takes decision, how the optimization, how the probabilities, everything is working. This is the first 2 weeks plan that we have, right? So in the third week, fourth week only, we will be getting more into algorithm based things. So I hope this is understood for you guys. So let's get into the important picture behind the ML, because initially AI is nothing but everything is subset, right? So the AI and everything are just a development. So just we start with majorly we guys will start with the machine learning only. So let's see what is when will the machine learning will be useful. So I am asking this to you guys, so you guys can even ping the answers in comment section. When ML will be useful, even AI, even Gen AI, everything will be useful. State it. So thing is that when we are having some difficulties in make something, like when experts are unable to explain their expertise. So like a kind of image recognition. If we are doing something we unable to do, then we can ask that to do. So image recognition. When experts are unable to recognize an image, we can train the data and we can ask. Then speech recognition, the TTL, those things just like text to speech, speech to text, those things just. And then even advanced driving car. So these things also we can make use of this. So these are some kind of things that we are doing. Then even we can ask this to, we can ask the ML machine, the ML trained machine also to do. So these kind of things we can do. When human expertise doesn't exist, that when we are not here, then the ML and machines can do these kind of things, is right. So that is an quite idea. Not we are making sense over that, but we are saying that as an example. When we are not here, then the machines can do. So that is for the thing. When experts are unable to explain their expertise, then the machine learning will be helpful. The solution need to be adapted to particular cases. Like everything, what are the things that we are currently proceeding and doing? That things all are everybody is training that to the model. So the testing. But one of the main fundamental part for this AI to do these things is that all problems are data. So we need a huge data. The big data we say, right? So that kind of data we need. All solutions are mapped. So based upon the data, all problems are data. From the data, there will be mapping of functions. That is purely mathematics. So those kind of mathematics they have used and initialize some kind of programmings. So that is already present there. So with the help of that only, now models and those things are itself, even if you ask a response to ChatGPT or any kind of things, it will even enhance their internal hidden layers. Like it will optimize, it will adjust the weights of each layers, and it will produce output, and it will adjust the weights and hidden layer things with based on the probability of output. So it will remap itself 1,000 times in order to give you a better response. So that is how these kind of mappings and those things will work. So these mapping and those things are, it will take care that we need not to worry about those. So when you guys understand behind mathematics, then you guys will have some quite idea over there also. So let's get into types of learning approach. So what are the types of learning approach now the ML is doing? Types of learning. Let's make it. What are types of learning? So majorly we can split this into two things. One is supervised and another one is unsupervised. So this is what, even in some kind of books they may ask us reinforcement learning also here, but this is the generalized thing. Only two types of learning, that first thing it has. Then we have come to other types of learning also. This is the primary things. So what we can do here in the supervised learning is that data labeled by human experts. Labeling, we will be giving a labeling, labeled input we will be giving. From that we will be making that of trained. So here the inputs that will be labeled data. Labeled in the case we are giving the answers. Labeled by expertise, like experts. In unsupervised learning, unlabeled data. Okay, so here unlabeled data. So this is the huge difference between these two kinds of learning. Okay, so this in unsupervised learning, there will be grouping and those kind of clustering parts will come. So that thing we can discuss later. So this for now, predominantly these two types of learning is available. Then there comes other types of learning. So other types, some other types of learning is also there. So first thing is that generative approach. So here generative approach. So in this generative approach, what will happen is that creating new data, that is to a machine. So generally this includes unsupervised learning only. So some unlabeled new data will be fed to the systems. Then there is semi-supervised. Semi-supervised learnings. So this is also similar to that, but small amount of labeled data will be available along with unlabeled data. So both labeled data as well as unlabeled data, both will be available. So then there come as a, I'm going to next page. So then there coming another one, that is self-supervised. Self-supervised learning. So here the thing is that the implicit labels are extracted from the data. So from the data, it will automatically extract the labels that extract some kind of data which are labeled. So that kind of thing it will do from the data. So then come last thing, which here is the reinforcement learning. So reinforcement learning. Okay. So thing is that actions are chosen based on rewards. Like here, the action will be given, feedback mechanism will be used. So this is one of the best approach that many guys will suggest. So reinforcement learning is that some kind of rewards and feedback action will be took place so that the machine can adapt itself to the new changes and it can give the better optimized output. So the researchers are suggesting some 7 steps in machine learning. So first thing is that gathering the data. So gathering data, then preparing the data like labeling and those part, right? So preparing data, then choosing the model, choosing the models or even algorithms, anything, choosing models. Okay, then training, then evaluation. Everything need to be tested, right? So evaluation, then tuning. I'm going this way. So tuning, then only they are giving us a prediction. Then we are in the prediction state because these kind of steps are already done for the models that we are currently using. So first thing is that gathering data, then preparing that data, and we are choosing that in the right model. Then we are training it, and then we are evaluating the thing. Then after the evaluation, we are tuning the model. From the tuning, we'll be using the model to predict the things. So this is the 7 step that ML engineer or any kind of engineer who have to do to make his or her model very perfect. Okay, but not these 7 steps may seems to be simple, but they have plenty of things to do behind it. So that thing, even during the course, I will be letting you guys to know so that you guys will understand it clearly. So there is two kind of problems in supervised learning. So supervised learning, we will be providing the labeled data, right? So one thing is that grouping, and one thing is that splitting, like classification and regression. So this is one of the major term difference. So classification and regression. Okay. So here we will, what we will doing here is that we will split the data. We means group it, classification, right? So here we will fit it. The data will be fitting to one kind of curve or things. So for an example, if we having one kind of box here, let me draw one thing. So here is there is one box, and here is there is one box. Okay. So here if you see, some circles are this side, some squares are this side, triangles are this side. Okay, I'm writing it smaller. Okay, here if you see, the data are in this way. Okay, so here what the best approach to class do is that here is a classification is the best approach. How we can classify is that we can classify like this. Okay, so 3 areas split it. But here how we can do is that we can't split it. Everything is same data. What we can do is that we can fit the data into one kind of curve or thing. So here we are doing a linear regression. So we can fit the data. So this is the two types of thing that we have in a supervised learning. So one is classification problem and another one is a regression problem. So this thing I thought to give an idea. So mathematics behind it. So this is one of the crucial thing that this is not necessarily needed every time. But if you guys know it, then you will know the ultimate thing. Like how we are studying 11th, 12th and then engineering maths, those things, right? Similar to that. So mathematics behind it. So I will be teaching this just 1 week of thing. After that, we will be kickstarting into other like CNN and RNNs, those things. So just in 1 week, 3 to 4 lectures only. So you guys can, if you need it, you can watch it, or else you can skip it. I will suggest you guys to watch it because everything we learn will not be wasted, right? So three things we need: algebra, probability, and optimization. And optimization. College students or just now passed out students will have a good idea over this one. But if you are an already started a career and you are 5 6 years of experience, then they will forget those things. So why linear algebra needed is that all the thing will be mapped. So if you are giving some input, so this is a text or prompt that you are giving, then that will be mapped into this kind of things like column and the transformers and those things are coming to picture, and our row will be transferred to column in order to that to each layers of node. So that will be given to each node like 1 2 3 4 like that kind of data will be split to this way, and we have to do. It's not a row to column conversion. We have a huge parameter to think over it. So that thing we will do. So one of the important thing is the mapping. So mapping of input to the model. So here will be model. Here is a model. Okay. So that thing we need linear algebra understanding. Probability is that every prediction is based on probabilities. So if you guys have two node thing, right? So then number of possibilities. So So this is a BSc, like binary channel that EC students may know. Here we will be calculating the probability. This is P0, this is P1. Here if we take this is R0 and R1, we have to calculate the probability. So what is the probability event of P0 under R1 intersection? Here what will be the probability of P0 under R1? Both will not be same because the channel it passing will be different, right? So here some weights will be there. Here will be A1, here will be A2, here will be A3, and this will be A4. So based on the weight, these values may vary. If it is 0.7 and if it is 0.3, then what's the thing here is that it will take this as a priority and the output will be 10. So here I am giving a sample input. So based on this 10, some kind of mappings will be there and output will be produced. Here also some mapping, linear algebra will come into picture. So everything here it is based on probability. So that thing we need probability understanding. So now we see right the A0, A1, A2, A4. These weights and these many layers will be there. These kind of patterns will be repeated in 3D. So that we have need a optimization. So calculus is one of the important thing come into picture. It will find out the references and it will find out all the clustering points that took into, and it will optimize the algorithmic flow, and it will adjust the weights, and it will improve the things in order to make the better decision. So these three things are very much needed. If you guys even not know, no worries. I will be giving you some quite understanding. This is not needed, but this will be a essential thing, some prerequisite. So from the next class, I will be teaching like linear algebra one lecture, probability one lecture, and optimization one lecture. That will be quite enough. No need. So in our journey, the first week will be starting with the history and these kind of behind mathematics. So I think next three lecture we can dedicate to this. After that, we will be kickstarting into pure ML like CNN, RNN, ANN. Those things we'll be seeing. Everything we will be seeing LLMs and capstone projects. Everything I will be guiding there. So stay tuned, guys. Like, share, and subscribe the channel. Please motivate me to post more videos like this, and we can see in the next lectures. Thank you. Stay tuned.